Welcome everybody, this is RAFT Polymerization 101 and okay, first of all, RAFT is the acronym of Reversible Addition, Fragmentation, Chain Transfer, Polymerization, and it is a type of living polymerization that also exploit the advantages of the radical polymerization techniques. We make use of a chain transfer agent, which in our case is a thiocarbonyl thio compound. And this is done to have control over the molecular weight and the dispersity of our final polymer. For this reason, we have to be very accurate in how we weigh our starting materials, how we transfer them in the reaction vial, and how we treat the solution before the polymerization starts. Another important thing that we have to pay attention of is that as it is a radical polymerization, the oxygen in our solution quenches the radical that we form during the polymerization. So before the polymerization starts, we have to get rid of all the oxygen in the solution, and this will be done with the freeze pump thaw technique using the Schlenk line. But I would say that we start with the transfer of our starting materials from the vials in which we have weighted them to the Schlenk to the Schlenk flask, that is this one. It is a 10 milliliters Schlenk flask. And in here you can see there is one of the monomer that we are going to use for this polymerization, because we are making the penipam co-methacrylic acid, and this is the nipam, so N-isopropylacrylamide, which we already weighted in the Schlenk tube directly. And also, you cannot see this, but it is inside, also a steering bar for the polymerization. Okay. Now we'll transfer let's say, ingredients for our polymerization in the tube. So we need the nipam, the methacrylic acid that is in this Eppendorf, and the RAFT agent, that is the chain transfer agent that I said before, and also the ABN, that is the radical initiator for our polymerization. We have to be very, very accurate in how we transfer the starting material in the Schlenk tube, as I said. So Alessandro will transfer it by using several washing, let's say. First of the IBN solution in all the Eppendorf, and after of three solvents, the solvent of our reaction, that is acetonitrile. Okay. So as you can see, Alessandro has added the ABN solution in one of the Eppendorf. It's the same if you start with the RAFT agent Eppendorf or the methacrylic acid Eppendorf. It's really the same. So you put the ABN solution inside, and then he will solubilize the RAFT agent that is here at the bottom of the Eppendorf. Okay, and then use the same solution in the methacrylic acid Eppendorf, and after that he will transfer all the solution in the Schlenk tube. Okay. One way you can solubilize the RAFT agent is with the vortex. So you can simply do that, or you can solubilize the RAFT agent by simply pipetting it up and down with a micropipette. You have to pay really lots of attention in this step, because this is the first step in which we are transferring the starting materials. So in this solution there is the initiator, the RAFT agent, and also the methacrylic acid. So if you drop something out in this stage, you will lose some of your starting materials. So you have to wait again them all. Okay, we can transfer it in the schlank tube. Perfect. We can cap the tube. Okay. Okay, an important thing here is to preserve the tip of the micropipette that we used for this first transfer, because it is stained with some of our starting materials. So we use a new one, of course, for the clean solvent that we are going to add in the solution, and then to transfer the final solution, we will use again this already used tip. Okay. The idea here is to do aliquot of solvent in order to transfer in the most quantitative possible way all the remaining of the starting materials in the Eppendorf. So Alessandro are going to do, I would say 2 or 3 washing. Okay, 3 washing of how much? 500. Okay, 500 microliters of clean solvent that, once again, in our case is acetonitrile. Okay. So Alessandro takes the free solvent and put it directly in one of the 2 Eppendorf. Even in this case, it's perfectly the same to start with one or another. Okay. Okay, at this time, Alessandro, take the clean tip and put it apart, okay, and put again the already used tip, okay, and use it to do the washing. Once he has finished with the first Eppendorf, he transferred in the second Eppendorf, okay. And even with this, he does some washing and then transfer in the schlank tube once again. And in the best case scenario, this is an operation that has to be done for the maximum times possible in order to reach the correct amount of solvents that you need in your polymerization. An important thing that here during this transferring that has to be underlined is especially when you have volatile solvents, like for example acetonitrile in our case, you have to be sure to have all your recipients near you, because the volatile solvents can drop out the tip, and you of course will lose some of your starting material or your solvents also during the transferring. So it is very important to have a holder near you, and also that the reaction recipient is near you and opened when you have to do this operation. After the washing, with the tip of the pipette in the Eppendorf, you go near the schlank tube. Please, Alessandro. Okay. You go near the schlank tube. Okay, opened it. And just when the recipient is open, you can transfer directly on, okay, in the tube. And also, if it is possible, the nearest possible respect to the solution. And as you can see now, you can see the steering bar that was already inside the Schlenk tube. Okay. And after that, you can cap the Schlenk tube once again, because we don't want to lose some of the solvent while it evaporates. This will be the last wash. So once again, first open the Schlenk tube, then take the solution, okay, and go directly in as near as possible to the solution. Okay, perfect. And at this point, the solution is ready to go. Okay, now that we have added all the starting materials that are the two monomers and the radical initiator, we have to put inside our Schlenk tube the internal standard for our reaction that will give us the information of the degree of polymerization. In our case, it's the DMF, and simply we take it from a vial and add the solution in the same way that we did for the other starting materials. At this point, we simply mix a bit the solution in a stirring plate. And it is important that the stirring plate in this moment, it has not to be hot, so room temperature. And after we have homogenized it, we will take around 30 microliters to use as the T0 times 0 of our reaction, in order then to determine the degree of polymerization once again. Okay, now Alessandro, who already has switched on this morning the pump, so it's important to switch it on when you arrive in the morning. We will freeze the trap. Alessandro has his goggles on. That is a very important DPI when you are working with the Schlenk tube and in lab in general, but especially with the Schlenk line. And now here there is liquid nitrogen, and very carefully Alessandro will freeze the trap and then put this support under the dewar to make sure that it stays in its position. Yeah, the important thing is to not add too much liquid nitrogen in the dewar, because you will get out the dewar. Okay. Okay, as you can see, you have to be very slow and very careful. Perfect, Alessandro, okay. And now Alessandro, take the support and fix it under the dewar. Okay. Okay, let's see if the dewar is stable. Okay, fantastic. And now, just to be sure, we put this stuff around the trap, so the liquid nitrogen will evaporate slower. Okay. Now we are ready to seal our Schlenk tube. So we first add some silicone grease on the cap, and then we sealed it with some parafilm on the outside. Silicone grease in this syringe. We take the cap, okay, put some grease on it, yeah, okay, more or less this amount, okay. Once it is quite homogeneous on the cap, you simply put it in the schlank tube and screw gently in order to, as you see, to make it translucent, transparent, so you are sure that all the grease is well homogeneous on the intern of the schlank tube. We cut three parafilm pieces, one that is a square one, the bigger one, and two that are two rectangles. Okay. The first one that we use is the square one. Okay. This one we fold it in two, okay, and then put over the cap of the tube. Okay. Okay. So the first parafilm piece is to do in this way. So the second one, that is one of the other two, is needed to seal the first piece on the bottom. Okay. Okay. Okay, perfect. And the third and last one is needed uh, to stop the cap very strongly to the tube. So Alessandro now will do some round, starting from the bottom and then going over the cap, and then again in this way. So Alessandro, go. Okay. Okay. On the cap, on the cap. Okay. Okay. Perfect. Okay, and in this way we are sure that during the freeze pump thaw and the polymerization, the cap will not go away. Now it's freeze pump thaw time, so we have to link the schlank tube to the schlank line. So Alessandro, just we take an exit and link them with this exit of the tube. Okay. Okay. And we have to be sure that this will be tight enough, but not too much, because this piece of glass can be broken. So, okay. Okay. Now that it's linked, it's very important to just follow the words. So freeze pump thaw, that gives the order in which we have to do the operations from now on. So the first important thing is to freeze our solution. So the first thing that we have to do actually is to open this valve linked to the pump. So is the pump for vacuum, and the upper line is for the inert gas, that in our case is the argon. First of all, with two hands, we open the vacuum valve. And in fact, as you can see, the noise of the pump changes, and also the value here. Okay. Now we put on this thing a little dewar with liquid nitrogen once again. Okay. And simply, exactly, put the Schlenk tube in it. It is important to maintain the tube always safe and still. Okay, important thing that I forgot is that we have opened the valve of the Schlenk line, but the very, very important thing is that the valve of the Schlenk tube here, as you can see, is closed, because if we have opened it, the Schlenk line valve with the Schlenk tube valve also opened, all the solution that we have prepared will be in the Schlenk line in this moment. So it is very important that during this first step, the Schlenk tube valve is closed. During this operation, all the freeze pump thaw operations, it is important to maintain still the Schlenk tube and move the dewar, because in this way we are sure that the Schlenk tube get not stressed in some way, and there is that we operate also only from the outside and not move the Schlenk tube. Now we have freezed it, and we can check it simply. Okay, going down with the dewar and see that it is frozen. Okay. Now that it is frozen, we can pass to the second step. Now, maintaining the Schlenk tube frozen inside the dewar with the liquid nitrogen, even in this case, is really important that the Schlenk tube stay frozen. We can open the Schlenk tube valve and do the pump step. In this case, we are taking out the air, so also the oxygen, of course, from the void on the tube. We just open the valve. Okay. Perfect. Even in this case, as you have to be sure that the noise from the pump has changed, and also the value here changes once again. Okay, now that we have opened the Schlenk tube valve, the upper air from the solution is getting out the Schlenk tube, and we are cleaning the solution from the oxygen. Now we wait sometimes. Normally this can be 5 to 10 minutes, not more than that. And after that we will move on to the thaw part. When your pump time has passed, you have to do the same operation as before, just in another way. So first, close the valve of the Schlenk tube. Okay. And instead the vacuum valve of the Schlenk line can stay open for the entire time of these operations. Okay. So take out the dewar. Okay. Pay attention during this operation to not touch the Schlenk tube with the dewar once you take it. Okay. So be careful here. Okay. And then we can move to the thaw step, because we take some water, simply water, can be tap water, it's not important to be the distilled one, okay, and put our Schlenk tube in it. Okay. In order to defreeze the solution and put it in its liquid state again. Okay, now the very important thing is to observe the bubbles that are generated from the solution. During this operation, during this step, it can happen that the solution gets up in your Schlenk tube, and it's not a problem because there are lots of air and oxygen that is flowing out the solution, and once it turns back in the liquid state, it will go on the bottom of the Schlenk tube, so it will be fine. In fact, for example, in this case, it's happening exactly that. So you can unscrew the tube and put the frozen part directly in the water, very carefully. In order to up the solution to go in the liquid state. You have to be very careful here because it's quite simple to break the Schlenk tube. Okay, and as you can see, it's again on the bottom of the tube. You can screw the tube again, okay, and wait till it is completely transparent. And as you can see, there are some bubbles that are going out the solution, and this is the oxygen, the air that was trapped in the solution and that is going upper the solution in the Schlenk tube. And in this way we can actually strip the air and the oxygen from our solution. And this operation, it is important to do it several times. I would say at least 3 times, even a 4th one can be useful if at the 3rd cycle you observe the bubbles again. Okay, when it is exactly at this stage, put out the solution, out from the water, and start again the freeze pump thaw cycle. So just to repeat, we are going to freeze the solution. After that, we will open the Schlenk tube valve. We wait the pump time, that once again can be from 5 to 10 minutes, and then close the valve and defreeze the solution. You also have to observe if the level of the liquid nitrogen goes down during this operation. It can happen. And in this case, you have just to refill it in the dewar directly. For now, it's fine. Now we are at our fourth cycle of the freeze pump thaw, and this is the last one for this polymerization. Now, while we are waiting for the pump time, you can already open the argon and we can flow the argon in the Schlenk tube. It is important before opening the gas that we make sure that every exit of the second line of the Schlenk line are closed. Okay, now we have to verify first that this valve is closed, and after that, and in fact we can see that even these and these, that both of them are at 0. So when we open the argon, it simply need a bit screw in anti-clockwise. We see that the pressure rises, and then we can open this valve. This one goes the other way around with respect to the first that we have opened. Okay. You will notice that this valve makes a bit of resistance when you are reaching the right flow. So, okay. Once you've opened even the second one, you have to observe this condenser. So you see that there is a positive flux because the argon goes here and then in this way. So you here see the bubbles, and in exit the argon goes from here. So these are, in it there is not bubbles, but there is in this part of the condenser. It is important that the bubbles are here and not here, because it means that the pressure is positive in this direction, that is the direction of the exit. In fact, if the pressure is positive, this means that there is no gas from the outside that is entering the Schlenk line. So this is the ideal setup in which we want to work. While the solution is defreezing, we will do some cycles, argon vacuum cycles, in order to be sure that in this exit of the line there are not any residue of some solvents or gases of any kind that can contaminate our solution once we will start the polymerization. Now, at the end of the fourth cycle, with the argon already opened, we can pass to the thaw step of the freeze pump thaw procedure. So, first, again, we close the Schlenk tube valve. We take the dewar and substitute it with the water. Okay. And at this cycle, that it is the last one, ideally we wouldn't observe any bubbles going out from the solution, but we will see. Okay, now while we are waiting, we can do the argon vacuum cycles. So with always this valve closed, it is important. We can close the vacuum valve. It's important to work with two hands on the Schlenk line. Okay, So we close the vacuum valve and we open the argon one. Once we open the argon valve, it's important to observe again the flux continues to stay positive, so nothing is going inside at the moment. If you observe that the bubbling decreases, you can simply go on the argon and open it a bit, but I think that it's fine. But just in case we increase the flux a bit, okay, it's fine like that. In the meantime, our solution is coming back to the liquid state, and as you can observe, there are no bubbles that come out the solution. At least just one or two, but it's fine in this case. Okay, and this is the ideal state of our solution just before start the polymerization. So in case you observe lots of bubbling in what it has to be your last cycle, it's important to do at least another one just to be sure that there is no oxygen in your solution. Okay, it's fine. Now we can close the vacuum, okay, open the argon, okay, and now before opening the Schlenk tube valve, it's important once again to check the argon flux. So we see that is positive because here there are the bubbles, and even here are the bubbles with a good flux. So we can open also the valve, the Schlenk tube valve. Okay. Okay, and if you pay really attention, once you've opened, you can observe here a bit of pressure that is the argon that is going inside the tube. And with this setup, so Schlenk argon valve opened and also Schlenk tube valve opened, we can transfer the solution in an oil bath that was already put at 65 degrees. That is the temperature that is needed for the initiator to start the polymerization, because it has a thermal activation, the initiator that we are using. It is important that the entire volume of the solution is under the oil, and the steering bar is at the right speed, that you can see it when this forms a little bit of vortex inside the solution. This is the optimal steering for the solution. Okay. From this point on, we can simply close the valve of the argon. Okay, once this is closed, we can close the argon valve of the Schlenk line. Okay. And also close the argon from the beginning. Okay. Okay. Perfect. And now we can leave the polymerization to go. And of course, if you want, you can unscrew it and leave the exit of the Schlenk line free because it isn't needed anymore at this stage.